Hello everybody, I hope everyone is having a great day so far. Today we're going to talk about solving fractional equations. Now on the board I have the steps to solving a fractional equation, and when we talk about a fractional equation, what we're saying is that it's an equation that has at least one or more fractions. And of course there's a few different ways to do things in math, and especially in algebra, but I'm going to show you one of the most convenient methods to solving a fractional equation. And although we could call a fractional equation an equation that has one fraction in it, typically fractional equation is used for an equation that has more than one fraction in it. So the method we're going to use today is going to be a method that eliminates our fractions after a step, so that way we're solving a regular equation that we're used to solving. So the first step is to determine your least common denominator out of your fractions. Okay, you could have 2 or 3 fractions or even more in your problem, but you're going to determine the least common denominator for all fractions. Okay, we have done that before with adding and subtracting fractions, so we're not going to review the procedure for finding the least common denominator except in our example problems. The second step is you're going to multiply every numerator, and that's how you multiply a number to a fraction, because you write that number over 1 of each fraction by the least common denominator. Okay, at this second step the denominators will stay the same. Okay, only the numerators will change. In our third step we're going to divide each numerator by each denominator. At this point our fractions will eliminate themselves and we should be left with integers. And finally the fourth step is to solve the equation. Since fractional equations are very difficult, please make sure you copy these steps in your notes. Okay, so pause the video in order to make sure that you have all these steps copied. Okay, do so right now, and again make sure you copy these steps in your notes. At this point we're going to move on to the first example. So for our first example we're going to do 1/4 plus x over 9 equals 17 over 36. Okay, and again there are other ways to solve this equation, than what we're going to do today, but I find this way to be one of the most convenient ways for students to solve a fractional equation because it eliminates your fractions. So the first thing we're going to do is determine the least common denominator between our 3 fractions that we have in this problem. So we have 4, 9, and 36. Well, 36 is a pretty large number, so if I do multiples of 4, it looks like, and I'm just going to write out a few here, but it looks like on the 9th one we are going to get, and I'm just writing this out the first time so you can see, oh, I made a mistake there, excuse me, so you could see getting our answer here, or getting our least common denominator. So again, if we do 9 multiples of 4, we do get 36. And also, if we do some multiples of 9, we also get 36. So 36 is going to be our least common multiple or our least common denominator. So that's our first step, is to find the LCD. Okay, so we found it, it's 36. If I use a common denominator, that will still be effective, it's just that my numbers will be a little bit larger. Okay? Now I'm going to clear this off. Our next step is going to be to multiply all the fractions by the least common denominator. So I'm going to put these fractions in brackets. Okay? I'm going to write that least common denominator over 1 because that's how I multiply a number to a fraction. So at this point, again, we're multiplying 36 to all these fractions. So really, in essence, we're multiplying it to the top numbers. The bottom or denominators will stay the same. So I have 36 over 4 when I multiply these two fractions. Okay? Now I didn't simplify it, so I'm just multiplying the numerators, keeping the denominator the same at this step. For my second fraction right here, we're going to get 36x over 9. Okay, again, we're just multiplying straight across. And for the last one, since 36 times 17 is a pretty large number, I'm not going to actually do the math on that. I'm just going to write it out as 36 times 17 over 36, and you'll see why in a second. You could easily perform the math on that if you'd like. Now our third step is going to be divide. So out of my first fraction here, 36 divided by 4 is 9. For my next fraction, 36x divided by 9 is 4x. And finally here, and the reason why I wrote this as 36 times 17 is because the 36 actually cancel, and we're just left with 17. So now we have a beautiful two-step equation left that's very simple for us to solve. Subtract 9, rewrite the problem, 4x equals 8, divide by 4, so you get an answer of x equals 2. Okay, if you want to check that answer, substitute it back into the original problem and add the two fractions on the left-hand side together. And when you get common denominators and add them together, I guarantee you will get 17 over 36. Okay, our second example is x over 9 minus 1/2 equals 1 over 18. Go ahead and try this problem on your own. So at this point, pause the video, try the problem on your own, and see how you do. The next 15 seconds will be blank. Okay, so hopefully you paused the video. Remember, you're in charge of your own learning here. So my least common denominator, if I look at my denominators, is 18. A lot of times the largest number will be your least common denominator, but not always. Okay, so especially if the right-hand side you're actually solving for the numerator or denominator on the right-hand side over here with the 1 over 18. So, but in this particular problem, my least common denominator is 18. Okay, I didn't write out the work for that. If you have any questions about that, please see me in class. Now I wrote it on the right-hand side of it this time. It really does not matter. What's important is that I'm multiplying it to all the fractions. Okay, so when we do this, I'm going to get 18x over 9. Again, I didn't simplify it yet. My second fraction, I get 18 over 2. And for my third fraction, I get 18 over 18. Okay. At this point, we divide our fractions out or simplify them. I get 2x for my first one. For the second one, we get 9. And for the third one, 18 divided by 18 is 1. Wow, a beautiful two-step equation left. I say beautiful because we took a highly complicated problem that looked very complicated for most students, and in 2 steps, we made it a two-step equation. Okay, so at this point, we simply add 9 to both sides, divide both sides by 2, so x equals 5. Okay, now here's one more example problem. I'm going to have you try one like this on your own. But here's a problem where if we look at our denominators, x is actually in the denominator. So how does that change the problem? Actually, let me change this to a 45. That's what I meant to write there. But how does that change the problem if there's a variable in my denominator? Well, it doesn't affect it that much, but you do have to be careful. And what happens here is, if I look at my denominators between 9 and 45 only, the least common denominator would be 45. Okay? But the problem here is we don't know what x is. X could be a multiple or a factor of 9 and 45, so it could be similar to that least common multiple or least common denominator, or it could be a totally different number that could affect it. So what we have to do is we actually have to multiply this least common denominator by a factor of x. So our least common denominator is actually 45x. So the simplest way to do this, or to think about it, would be if you have a variable in your denominator, figure out your LCD for your other fractions, and then include that LCD or that variable in your LCD, I should say. So my LCD is actually 45x. So again, if you have a variable in your LCD, it's going to change your LCD by a factor of that variable. So when you figure out your least common denominator for your fractions, put that variable with your least common denominator. Okay? So now we're going to do just what we did before, excuse me. So I'm going to multiply 45x to all these fractions. Okay? I'll put it over 1. 45x times 4 is going to be 180x. So 180x over 9. Notice I keep the denominator the same because we're multiplying by 45x over 1. For the second fraction, 3 times 45x is going to be 135x over x. And for the last fraction, because the number I'm multiplying by is the same as the denominator, I'm not actually going to multiply those numbers. I'm just going to write the multiplication out and keep the denominator the same. Okay? You could actually, if you like to, you could actually multiply 47 times 45 very easily and write that answer instead of what I have over here. Okay? But the reason why I do that is I'm going to show you a trick here. Now we can divide these fractions out. Well, here I get 20x. On my second fraction, I actually get 135 because the x's cancel. On my last fraction on the other side of the equation, the 45's cancel because multiplying and dividing by 45 are inverse operations. So we actually get 47x. Okay? So we actually have two variables now. So now I have to get the variables on the same side by subtracting 20x. So we have 135x equals 27. And if you divide both sides by 27, you will get an answer of x equals 5. Okay? You may have to write that one out to check it, or just simply use your calculator. But if we write it out, you could see we do get 135 back. Okay? So x is positive 5. Thank you very much for your attention. Here's a cool, funny math picture to end it. We're not doing graphing of two variables yet, but we will get to that very soon in the year. So it's a raccoon saying, "I see you have some graph paper. You must be plotting something." Very funny. So have a fantastic day. If you have any questions, please let me know in class. Thank you very much.